Alright, welcome back. This is kind of going to conclude the first measurement I've done with the sensor. So this part of the report is going to, or this part of the video is going to kind of explain how I went about using my MATLAB algorithm to determine the position of the magnet. First of all, before this, I performed a calibration of either, and this is shown in this Excel file here. Basically, what I did was I just restricted the to just the z direction, so up and down. And by doing this, I could determine the expected field from the magnet I was using, and determine the equation that would relate the voltage coming out of the magnetic Hall effect sensor to a final field value. And to do this, it was a pretty simple calculation. I just and it ended up being linear as expected, so that's excellent. And I just got this equation here, and I did the same thing for the second sensor. So taking the voltage values I got from the reading I just showed you in the video, for the first sensor I got a field of 8.05214 times 10 to the negative 4 Tesla, and for the second sensor I got 8.3677 times 10 to the negative 4 Tesla. Units are important. But anyway, I done MATLAB algorithm, which is a Levenberg Marquardt algorithm for minimizing, for optimizing the results of nonlinear overdetermined systems. So say I had 4 sensors or 5 sensors at my disposal, and I still wanted to measure just a two-plane, two unknown variable. I could still determine that as it is an overdetermined system. So, but yeah, so in this algorithm here, the main things you, I guess, should understand are that this is a function handle which just takes in a value of x and calculates what the result is. In this case, will represent the z variable, the up and down motion of the magnet, and x2 will represent the action or the lateral movement back and forth between the two Hall sensors of the magnet. Also, there is 2 equations listed for each sensor. This is the first equation listed. Oops, sorry, right here. And the second equation is the unhighlighted button here. Now, to edit these equations are just assumed to equal 0. That's how the algorithm solves it. So in order to change that, this is the magnetic field value that you have to input. And to do that, I just put in the value of this is for sensor 1, by the way, 0.000805214, as mentioned before. Ooh, don't have 2 decimal points. And I did the same thing here for a point. Oops. Probably just give me a moment here. Oops. 0.000867. Okay. So, just want to double check that I have everything inputted properly. Yep, looks good to me. And this is the algorithm that solves it, so it just minimizes the function, finds out what the best value is. This is the this highlighted portion here is the 2 equations with the 2 unknowns, and this is an initial guess. I set my initial guess to be the bottom left-hand portion of the plane, so that'd be 2 centimeter, 2 centimeter. So, or sorry, the bottom right corner, close to the bottom right corner. That'd be 2 centimeters in the z direction, 2 centimeters in the x direction. so. We can run this now. Just copy it into and hit enter. And it gives us a value here, as you can see, 4.21 centimeters. That's pretty accurate. And 1.22 centimeters. And if you remember, okay, so the center of the plane is where we were measuring that magnet, and the center of that plane is 4 centimeters, as mentioned, between the 2 and 6 centimeter plane window. So that's this 4 centimeters here, 4.21, fairly close. And 2.54 centimeters is the entire x-axis. Divide that by 2, you get 1.27 centimeters. So 1.22 centimeters is also a pretty accurate reading, considering we have only 2 sensors measuring this. There's no overdetermination. So again, this is a minimization. Another thing to consider is that, I mean, I was moving that big traverse around, and it's heavy, and it's not going to be exactly in the right position. So this was about an approximation, and it ended up a pretty good reading from that. So, I mean, to only be off 2 millimeters isn't really that unexpected, considering the amount of sensors I had and how the system is is not overdetermined. So that ought to do this part of it. I'll put the magnet in a different position and see its accuracy in another position.